Yes, hello class. Is this audible? Arnav and Iram.
Yes.
Alright. So in the last class, we had started with physical world and measurement. Iram, is it audible to you? Iram
Yes,
Hafiza?
ma'am. Yes, ma'am.
Alright. Alright. So see, Arnav, that day we had a lot of network issues, so I'm repeating it from the starting. So whatever points you missed and you were not able to understand, you can revise it. And Iram, you will also be able to know what did we do in the first class. So see, this is your first unit, physical world and measurement. This comprises of your chapter number 1 and 2 of NCRT. So introduction to physics, that is from your chapter NCRT chapter number 1. Then your dimensional analysis portion, NCRT chapter 2. And then error analysis. Error analysis basically whenever you use instruments, and there's always some chances of error. Then that we'll be covering, and that is under your chapter 2 of NCRT. So error analysis is important in your practicals also. You will be getting screw gauge and different lab instruments, and there you have to calculate error. And then it's the measurement of length, mass, and time. These are your fundamental quantities. So this also comprises your NCERT chapter 2. So Arnav, you had noted down all the points on the previous day, Monday?
Yes, ma'am. Most of them.
Most of it. So if any point is missing, you can note it down. Aram, I think it's better for today's class only. Just take the screenshots of all these pages, and then after the class, you write them down, because Arnav has already written it, so you can take the screenshot. And from the, all right. So we had started with dimensional analysis. Now in dimensional analysis, you have to understand what is meant by a physical quantity. See, any quantity that you can measure with the help of any other thing or directly by looking at it, that is considered as a physical quantity. Like if I give you your pen. I give you your pen and I ask you what is the length of this pen. So with the help of a scale, you will be able to calculate what is the length of this pen. Let's say it is 15 centimeters long. So 15 centimeters is what? 15 centimeters is the length of this pen. It means length is, we are able to measure length. Length can be measured. That means length is what? Length is your physical quantity. If you are able to measure any quantity, then you call it as a physical quantity. Now, physical quantities are also classified into two categories. One you have as the fundamental category, one you have as the derived category. So, Aram, whenever you want me to stop, just let me know for taking the screenshots. Otherwise, I'm scrolling. All right.
Yes, ma'am.
Okay. Now see, beginning with fundamental quantities are those quantities that cannot be expressed in terms of any other physical quantity. See, what is the meaning of this statement? This statement basically means that we have some basic quantities, and with the help of those basic quantities, we can make other quantities. You cannot use other quantities to make these. With the help of these, you can make others. So these are known as fundamental quantities. I'll give you an example which will be utilized in your upcoming chapters. We have velocity. And velocity, I think you must have studied in your 9th standard also. Velocity is what? This is distance, displacement covered by time. So displacement or distance, let me use the word distance because I think you must be familiar with the term distance. Then when we'll be doing it, then in your lesson, then you'll be able to understand. See, distance is actually a fundamental quantity. Time is a fundamental quantity. You cannot define distance. Distance basically means length. You cannot define time. But with the help of distance and time, I am able to define velocity. It means distance and time. These are what? These are my fundamental quantities. So in the the SI system means Standard International System. You have 7 fundamental quantities and 2 supplementary quantities. So without the usage of fundamental quantities, you won't be able to solve any question of this chapter. So it's better you learn all those fundamental quantity. And remembering their SI unit is also important because SI unit is used a lot. So if you remember the SI unit, you will be able to derive the SI unit of other quantities. For example, if I talk about velocity, the example that I gave you, if I say the SI unit of distance is meter and the SI unit of time is second, so you can easily figure out that the SI unit of velocity must be meter per second. So this is important for calculation of your SI units as well. So we had seen all those 7 fundamental quantities. These were those 7 fundamental quantities. First one is your mass. Mass is represented by this letter M, and we'll be using these 3. At least these 3 we'll be using in today's class: mass, length, and time. So SI unit of mass is what? This is kg. SI unit of length is meter. SI unit of time, this is seconds. Then you have temperature. Temperature is the heat that you also have in your syllabus, temperature. In your second term, you have a whole unit on temperature. So in temperature is usually represented through theta, or sometimes it is also represented through this capital K. And the SI unit is Kelvin, which is usually written as K, 200K, 400K. That means 400 Kelvin. So Kelvin is the SI unit of temperature. Then you have electric current. This whole electric current is dealt in your 12th standard. When you'll go in 12th, then you'll be dealing with electric current. So electric current SI unit is ampere, and this is represented through capital I. So in dimensional analysis, whenever you write M, L, T, theta, I, you should be able to understand what is the meaning of it. Now these two are not used often. Till electric current only most of the questions will be solved and you will be able to understand. Regarding luminous intensity means the amount of light that is coming. The SI unit of it is candela. And then you have amount of substance, and the SI unit is mole. So amount of substance, you have a complete chapter in your chemistry, mole concept, to have amount of substance. So you will deal with it. Some of the concepts will be utilized in physics, otherwise you will study that in chemistry. So these are the 7 fundamental quantities that you have. Apart from these 7 fundamental quantities, you have supplementary quantities. Means fundamental quantities are basic. Definitely all the 7 fundamental quantities are basic to you. But just to support these fundamental quantities, 2 quantities are additional required. These quantities are basically angle. One is your plane angle, other one is your solid angle. So plane angle means what? Plane angle means the angle in 2 dimensions. If you are able to draw 2 lines like this in this manner, and this is theta, then I call this, whatever this is formed, I call this as a plane angle. And the SI unit is radian. See, remember the SI unit of angle, because when you will be doing rotational and motion, you have it in your first term only. When you will be doing rotation, radian will be used a lot, because there you consider all the terms in terms of angle. So plane angle is represented through theta again. Theta, you must be using it earlier, sine theta, cos theta for angle. So for plane angle, you have it as theta. This is the plane angle. Then for 3 dimensions, you have solid angle. 3 dimensions means what? For example, if you have a cone with you, the curved surface of the cone must be subtending an angle at the vertex. Now, whatever angle is being subtended at the vertex, this is known as a solid angle. Solid angle means 3D, angle in 3D. Like if you take the cone of an ice cream, this portion at the end that you get, this is what? This is your solid angle. So this is represented through this symbol, omega. This is the symbol representation of your solid angle. And the SI unit is steradian. Just add STE in front of radian. That makes your solid angle, steradian. Radian is the SI unit of plane angle. Steradian is the SI unit of solid angle. These are the 2 supplementary quantities. So we had 7 fundamental quantities: mass, length, time, temperature, electric current, luminous intensity, and amount of substance, and 2 supplementary quantities: the plane angle and the solid angle. Now, derived physical quantity, this was the last topic that we covered. Derived physical quantities means when we use fundamental quantities and express it in terms of other quantity, that new quantity that is formed, you call it as a derived physical quantity. For example, the example I was giving you about velocity. Velocity was what? Length by time. So for velocity, you have a separate chapter. In the next chapter, upcoming chapters, you will be dealing. See, this is the very basic chapter for your physics. From the next chapter, motion in 1D, motion in 2D, motion in straight line you have, and all these chapters, you require the basic knowledge of physics. So this chapter deals with that. So see, length was what? Length was a fundamental physical quantity. Time was a fundamental physical quantity. Now, with the help of these two fundamental physical quantity, if I take their ratio, it means if I divide both of them, I am getting what? I am getting a new quantity. So this new quantity that is expressed in terms of fundamental quantities, these are known as derived quantities. So velocity is what? Is it a derived quantity or a fundamental quantity?
Derived?
Derived. Definitely it is derived. Reason? Because it is expressed in terms of distance and time. So velocity becomes what? Velocity becomes your derived physical quantity. So you have various examples, like you have velocity, you have force, you have energy, you have resistance. See, reason, for example, force. Force can be expressed in terms of mass and acceleration. So force is expressed in terms of mass and acceleration. It means force is a new quantity, mass is a fundamental quantity. See, acceleration is also a derived quantity. Why? We'll be studying in motion in a straight line, acceleration also. So acceleration is what? This is velocity divided by time. So velocity, acceleration, we are able to express in terms of velocity and time. It means we are getting a new quantity. So acceleration is what? This is also a derived quantity. Now with the help of acceleration and mass, we are able to define force. So this means what? Force is also a derived quantity. But at the end, you are not able to define time. You are not able to define length with the help of any quantity. That's why we call these quantities as fundamental quantities. Is it clear?
Yes, ma'am.
All right. Arnav, is this audible to you? I think you lost your audio.
Yes. Yes, ma'am.
It's fine now?
Yes, ma'am.
All right. Now see, this was the basis of your lesson. Now we'll be starting with the dimensions. How to write the dimensions with the help of fundamental quantities only. So the first three quantities, which are very basic, which we had covered, mass, length, and time. With the help of these, first let us see how to use these combination to write the dimensions. So let's understand how to write the dimensional formula, and the dimensional equation. See, dimensional formula is written here. For example, if I give you any quantity, like if I give you area. Area is a quantity. Area can be measured. It means area is what? Area is your physical quantity. Any quantity that you are able to measure, that is known as your physical quantity. So area is what? Area is the product of length and breadth. Now, Aram, you tell me, what is the fundamental quantity in this? Which one is the fundamental quantity among this?
Length?
Length. See, length, breadth, both. Both are what? Both are actually the length only. You are able to measure breadth, you are able to measure length. And if you take the product of length and breadth, then that becomes your area. So, length, you know, but see, breadth is what? Breadth is also a length only, no? You are able to measure a side that is expressed in terms of meter. So this is also length only. You have to relate it with the fundamental quantities that you have seen. See, breadth wasn't mentioned in this. We didn't have breadth in this list of fundamental classification by the SI system. So what you do? How can you relate breadth? Will breadth be equivalent to mass? Will breadth be equivalent to length? Will the breadth be equivalent to time? So definitely it will be equivalent to that length. We have only these 7 fundamental quantities. If needed, we'll be using the supplementary quantities. So breadth can be expressed in terms of what? Length. So this becomes what? This becomes length square. And how do we represent length? We represent length with the help of capital L. This becomes square. So now see, if you have to expand it and write it, is there any mass right now? Are you able to see any mass in this equation? Final equation? No, there is no mass. Are you able to see any time? In this equation that we have, you're not able to observe mass. Are you able to observe time? Is capital T over here?
No, ma'am.
No. So this means we have the dimensional formula of area as L square only. Now see, it is usually written as MLT. In the form of MLT, you will be seeing in your NCERT also. In your part 1 of physics, you will be seeing it in terms of MLT. So since no mass is there, mass will be what? 0. Length is what? Length is 2. And time is what? Time is again 0. So this is the complete dimensional formula of area. Is this clear? Any doubts still here?
Ma'am, but why mass and time is there?
Mass and time are there because this is dimensional equation. I'll help you. See, mass and time are actually 0. So you can write it in terms of L square only. Even if you write it as L square, that is understood. It means mass is 0, time is also 0. But this is a standard way to represent. This is how you write dimensional formula of any quantities. You will be expressing it in terms of mass, length, and time. See, we cannot write all the 7 quantities and put 0 in front of it. So the dimensional formula is written usually in terms of MLT. Even mass and time are not there, so you can put a 0. So even if you omit it, that doesn't matter. Even if you don't write it, you will be still allotted marks. Reason? Because L square is important. So this was mass. So you have to represent it in terms of mass, length, and time. So see, what did we do? We wrote the formula as what? L square. Now see, this 2 that you are getting, this power 2 that you are getting in front of the L, this is your dimension. This is your dimension. And the L square that you are writing, this L square, this is the dimensional formula. This is the dimensional formula. If anyone asks you what is the dimension of area, you say it is 2. And this whole A is equal to L square. This whole complete statement, this is known as dimensional equation. This whole is known as a dimensional equation. So what did we do? L to the power 2. 2 is the dimension. This L square, this is the dimensional formula of what? Area. And this whole complete statement, area is equal to L square. This is your dimensional equation. Yes, any doubts till now? Arnav, is it clear?
Yes, ma'am.
All right, let's do one more example, then you can note it down. I'll give you time to write it down. And Aram, from here, you also start making notes. And after the class, please write down all the points that were missed in the previous class. All right.
Yes, ma'am.
So let's take one more example of volume. See, volume is what? Volume can be written as the product of length, breadth, and height. That's what you have studied from your lower classes. This is how volume is expressed. Now, in this fundamental quantity that you are able to observe is only length. So length will definitely be there. But breadth and height, both of these are not mentioned in the list of SI systems fundamental quantity. It means we have to understand what is length and height. So among all these quantities that we have studied, all these 7 quantities, length is there. What about breadth and height? How can they be expressed? In terms of mass, in terms of length, or in terms of time?
In terms of length.
In terms of length. So it means we can write breadth as equivalent to length. We can write height also as equivalent to length. So this becomes what? This becomes length to the power 3. That is length cube. Now volume is expressed how? L, this is the length, to the power 3. If you want, you can write M0, L3, T0. Even if you write this, both of them are correct. Either write this or write this. Okay, Arnav, you tell me, what is the dimension in this?
Of, ma'am? Can you repeat?
What is the dimension in this? The way we had seen dimension for area. What is the dimension now? See, 2 was the dimension of area. Now look at the
Yes.
equation. So what is the dimension? Try it yourself.
Dimension will be m is to the power 0, l to the power 2, and t to the power 0.
That is your dimensional formula. See, there's a difference between dimension, dimensional formula, and dimensional equation. Whatever power you are getting, no, all the power, that is your dimension. The way L square, in L square we had 2 as the dimension. So in terms of volume, what will it be?
It will be in volume, it will be 3.
It will be 3. Correct. Perfect. This will be 3. Why? Because L to the power 3 is there, and whatever power you have, that is your dimension. Now,
Yes.
what you were referring to, Arnav, that was the dimensional formula, this L cube. L cube, or this whole M0, L cube, T0, this is known as dimensional formula. So this is dimensional formula. Whenever you are asked to write the dimensional formula, be careful. Now, this whole statement, V is equal to L cube, this whole statement, including volume, this becomes your dimensional equation.
Okay, ma'am.
Clear to both of you?
Yes, ma'am.
So
Yes, ma'am.
first copy down these 2 points of dimension. And if you have any doubts, you can ask me. If you are not comfortable in unmuting yourself, you can type the question and send me. Written?
Yes, ma'am.
Arnav, what about you?
Just a minute, ma'am.
All right, take it.
Yes, I'm done.
All right, see, now this is density. The next example, now this you will be trying on your own. Density is what? Density is expressed as the ratio of mass and volume. So both of you just take 2 minutes and try. What will be the dimension? What will be the dimensional formula and dimensional equation of density? Mass is a fundamental quantity. How can volume be expressed? We have just done the example of volume. How can volume be expressed? Mass is already a fundamental quantity. Just see what is the dimension coming, what is the dimensional formula, and what is the dimensional equation. Whoever gets the answer, submit it in the chat box. Yes, Arnav, your answer is correct. See, how can we write mass? Mass can be written as capital M because it's already a fundamental quantity. How can we write volume? Aram, you tell me. How can we write volume?
L cube.
L cube. See, we had done it right now only, no? How to write volume. Now see, whenever this denominator will go in the numerator, powers will get changed, means the sign will get changed. So this will be what? M will be there. This will be L to the power minus 3 if we put it in the numerator. Now see how to write the final result. Density, that is usually represented by the symbol rho. This is density. This is m1, m to the power 1, L to the power minus 3, and since no time is there, t to the power 0. That's how you write the dimensional formula. Now see, dimensions, all the powers that you are getting, the power 1 and the power minus 3, these are the dimensions. Power 1 and power minus 3, these are the dimensions. Now, what will be the dimensional formula? This becomes your whole dimensional formula. So under whatever you have submitted, that is your dimensional formula. Iram, it won't be only minus 3. It will be minus 3 as well as plus 1. All right, because you cannot neglect this to the power 1. All right. So this becomes m to the power 1. L to the power minus 3 to the power 0. This becomes what? This becomes dimensional formula. And if you write the complete statement, rho is equal to m L to the power minus 3. Even if you write it till here, no need to mention time because time is not there. This is also correct. You can write it in terms of m L to the power minus 3. So this becomes your dimensional equation. All right, so just note this down as well, then we'll do something else.
Done, ma'am.
And what about you, Aram?
Done.
Done? Oh. So see, let's do some more physical quantities. This chart you have to remember, we'll be dealing with seven physical quantities and how to write their dimensional formula. SI units you have seen, but with the help of the dimensional formula also you can calculate the SI unit. So I'll be writing down the physical quantity over here. Then the formula. Formula means a general formula, like the formula of velocity is length by time, that general formula. And then the dimensional formula. This is the dimensional formula. And then the SI unit. And this is the CGS unit. All right. So let's deal with the first one. First one is your distance. Now you have understood how to write the dimensional formula. Only this part was unknown to you, no? The rest of the things you are aware of. So we'll be dealing with this. And see, many of these will get covered as you reach the end of your class. From every chapter, you have certain formula, you have certain topic, and with the help of the formula, you can easily write the dimensional formula. So distance. So distance has no formula. Distance, or if I write displacement, this is length only. So dimensional formula will be L to the power 1. SI unit is meter and the CGS unit is centimeter. Easy? Clear? Yes, class.
Yes, ma'am.
Now, second one, let's see acceleration. No, let's see speed first. Let's see speed or velocity. The next chapter that you have, motion in a straight line, that we deals with all these: distance, displacement, speed, velocity, acceleration. So the formula of speed is what? This is basically distance divided by time. Or for velocity, you also have displacement by time. This is displacement divided by time. So The formula of speed is what? Distance by time, and formula of velocity is displacement by time. Now, how do we write distance? L to the power 1. How do we write time? T to the power 1. So final formula becomes what? L t to the power minus 1. L to the power 1, t to the power minus 1. Clear?
Ma'am, for distance we have a formula, right?
Distance has
Speed
no
into
formula.
time.
Yes, see, speed into time, but that is derived from this only. Main formula is this. Now, if you are aware of speed and if you are aware of time, you can calculate distance. But the actual formula, the original formula is this. Velocity is expressed in terms of distance and time. See, when you will be dealing with this chapter, no, this is a very different chapter. The first chapter that is provided in your NCERT is this chapter. This is a very basic chapter. The next chapters and the whole physics of class 11th and 12th, these are not like this. So you will be having whole class on speed and velocity. Then you will be able to understand why are we writing speed as distance and velocity, what is meant by velocity. All right, so slowly with passage of time things will get clear. But for just now you understand this is distance. Velocity is expressed in terms of distance, but if we know velocity and we know time, we can calculate distance. All right.
Okay, ma'am.
Now, the SI unit will be what? Meter divided by second. So this becomes meter per second. Similarly, this will be centimeter divided by second. Seconds is same in SI unit as well as in CGS unit. So this becomes centimeter per second. Now let's deal with some more quantities. Let's deal with acceleration. So now don't go into the meaning that we are not discussing acceleration, we are not discussing speed, we are just writing the formula. Because your main focus is how to write the dimensional formula. See, in your exam, in your questions, in your test that you'll be getting, what you will get is, you will get a whole formula. That might be from your second term, that might be from your first term. You will be asked to write the dimension and the formula will be provided to you if it is not a basic one. So all the basics formula like speed and acceleration, this I am covering. But very complicated formulas are also there in your syllabus. In fluid mechanics, there are very complicated formula. In thermal unit, there are complicated formulas. So then there in your exam right now, what you will get is, you will get the formula and you will know you have to give the dimension. So right now we are not understanding what is acceleration, what is speed, what is distance. Right now we are just trying to understand how to write the dimensions and the SI unit. This is important. So acceleration is what? Acceleration is the change in velocity by time. So I'm writing only velocity by time. This is actually change in velocity by time. So velocity was what? Velocity we have just seen, velocity or speed. This was L to the power 1, T to the power minus 1 divided by what is time? Time is T to the power 1. So how can I write the dimensional formula? I can write it as L1. Now see, when this T will go in the numerator, this will also become minus 1. No, when this T will go in the numerator, this will also become minus 1. So your final formula becomes L to the power 1, T to the power minus 2. If you wish, you can write it as M0 also. Even if you don't write M0, this is correct. So SI unit will be what? Meter per second square, because 2 times are there. This becomes meter per second square and this becomes centimeter per second square. Clear till here?
Yes, ma'am.
Okay, so do one thing. Write down these 3 points and I'm giving you fourth quantity. I'm writing down the formula. Then you will tell me what is the dimensional formula. Okay, first copy down these. We'll do a whole complete chart of it. It can happen you might not get the formula of all these quantity which we are discussing right now. Apart from this, if it's the complicated form one, you will be getting the formula. If you have any doubts, you can ask me. make it in the form of tabular form only. Okay, we put straight lines in between these so that you get a whole complete chart ready with you.
Done, ma'am.
So this is momentum. The formula is mass multiplied by velocity. Quickly tell me what will be the dimensional formula. Both of you, just try it and send me your answer in the chat box. Yes, Aram, you are right. See, this is very easy. You know the formula of velocity. You just have to multiply it with mass. See, mass is what? Mass is m to the power 1. Velocity is what? Velocity we had seen L to the power 1, T to the power minus 1. So if you multiply both of them, the whole complete formula becomes what? This becomes m to the power 1, L to the power 1, T to the power minus mlt, or you can directly write mlt to the power minus 1. Mass is what? Kg multiplied by velocity is meter per second. So this will be in terms of CGS unit. In terms of CGS unit, this will be what? This will be grams per centimeter. Yes, Arnab. Yes, Arnab. Your answer is also right. I'm giving you more parts. Try that. Yes, both of you are right. And tell me the SI unit as well.
Newton.
Newton, ma'am.
Newton. SI unit of force. This is Newton. Correct. See, CGS unit of force. This is 9. Okay, next part I'm giving. That try. Try that part. And now this you have sent it for work done.
No, ma'am, I by mistakenly wrote the wrong. One
Okay,
second.
okay. Okay, Aram, there's a slight error in your answer. Arnav, yours is correct. See, I'll help you. Force is what? Force is this M L T to the power minus 2. This is force that you have seen. Displacement is what? Displacement is simply L multiply. L will get square because L1 is there, L1 is there. So this will be M L square T to the power minus 2. And the SI unit of work done, no, this is joules. SI unit of work done, this is joules. And the CGS unit is Earth. Remember the SI unit and CGS unit because in the next chapters that we have to deal with, this concept will be utilized. So I'm again repeating, don't consider that 11th physics is this much easy by writing the dimensional formula. This is just the basic of it and you should know all the basics, SI unit, CGS unit, dimensional formula. Okay, one last part. Try it calculating. Tell me the dimensional formula for pressure. I'll write down the formula. Formula is force by area. Now, not only send me the this dimension formula, also send me the SI unit. SI unit plus dimension formula. Quickly, both.
Ma'am, I don't remember the SI unit. I sent the dimensional formula.
All right. SI unit, don't tell me in terms of the specific SI unit only. You can tell me it in terms of forces SI unit divided by SI unit of area. Force SI unit is what? You know. Area SI unit is what? You know. Divide that. Aram, yes, correct. Aram, I think last one is T. I think by mistake you wrote it as L. No?
Yeah, sorry, ma'am.
Yeah, it's correct. Newton per meter square, correct enough. And you know, 1 Newton per meter square is what? Pascal. So yes, both of you are correct. See, force is what? Force is M L to the power minus 2, T to the power minus 2 divided by L square. From here you can see 1 L will get cancelled. We'll be left with M L to the power minus 1 T to the power minus 2. So SI unit, if you forget the SI units, you can always write it in terms of this Newton per meter square, which is known as Pascals. Fine. And the CGS unit is dyne per centimeter only. We write it as dynes per centimeter square. Dyne per centimeter square. Just complete the list, just revise it once more, see if you have any doubts in any part. Then we'll do one question. How do questions come in your exam? Seen? Done? Any doubts?
No doubts, ma'am.
All right. What about you, Aram?
No, ma'am.
All right. Okay, one more thing that I'll tell you that will ease your calculations. See, you know what is the dimensional formula of work done now? This is the dimensional formula of work done. If you have any kind of energy with you, no, if the question gives you any kind of energy, be it potential energy, be it total energy, be it kinetic energy, if the question says it gives you any kind of energy, see the dimensional formulas of work done and all the energies are same. So no need to think of the formula if you are unaware of. If you know the dimensional formula of work done, that is only the dimensional formula of energy. So I just make a note point and write this as well. Work done and all types of energies and all types of energies have same dimensional formula. Have the same dimension formula. So if you know one of it, you can know the other one. That is what? This is m L to the power 2 t to the power minus 2. Now let's do how do questions come in your exam. Right, make this point as well. And see, when you'll be dealing with gravitation, no, gravitation is included in your NCERT chapter 1 only. So there you will see gravitational force formula. This is capital G, this is a gravitational constant, mass 1, mass of second body divided by r square. So I'll write down what are all these. F is the force, M1 and M2, these are the masses. Then R is what? R is the separation. Separation means length. Separation means you can take it as length. And G is a constant. This is universal gravitational constant. I think you must have done this gravitational constant in 9th, I think. Universal gravitational constant. So now I have told you. Now tell me, just calculate and tell me the dimensional formula of G. Calculate dimensional formula of G. So you know M1, you know M2, you know R square. Now you know the dimensional formula of force as well. Quickly tell me what will be the value of G. Take 2 minutes and I'll discuss. Let me discuss it only. See, F is what? F is written as capital G M1. Okay, so Arnav has solved as well. Very good, Arnav. Very good. Correct answer. So quickly you have done it. See, G M1 M2 divided by R square. Now capital G is what from this? You can multiply F into R square divided by M1 M2. That will be the formula of this gravitational constant. Now put values of each. What is the dimensional formula of force? Force is m L to the power t, L t to the power minus 2. R square will be square of length. One mass is m, other mass is also m. Now see in this. This will be m square. This will be L cube. L multiplied by L square. This becomes L cube. And in the denominator, what you have? M square. So when this m will go up, this will be m L cube t to the power minus 2. And this will be m to the power minus 2. Now plus 1, this is 1 minus 2. What you have? M to the power minus 1, L cube t to the power minus 2. This is the dimensional formula of G. Aram, tell me, is it clear to you or should I repeat?
Yes, ma'am, it's clear.
Yeah, all right. Just write down the solution and this question. So I'll stop here today only. Today I'll stop here. Then in the next class we'll do further. If you have written it, just let me know.